With that, it's my pleasure to introduce our speaker, Dr. Rob Benson from the geology program, talking about acid mine drainage.
Thank you, and in good form, I'm going to plunge you all into almost darkness this time. Now, for those of you who have been in here before, isn't this nice gradational lighting good? I love this. So, thanks for getting that. That's romantic acid mine drainage talk. Okay, so thank you again for coming. This is always a wonderful privilege to get and come and speak with all of you folks. So I'd like to, first of all, start off with what is acid mine drainage? Okay, you don't have to answer that yet. Okay, so the official abbreviation is AMD. Now, for you tech guys, you remember AMD from a long time ago, right? Was that competitor for Intel? Yeah. Okay, but this is a different one entirely. And two of the big culprits for acid mine drainage, and what I'm going to be talking about today, are up here. You notice these are two big, beautiful specimens, and there's a nice sign in the front that says, "Do not touch them." Now, is that because I don't want you touching them because they might break? That one's 165 pounds. This one's about 150 right here. They're both sulfides. This one's chock full of lead. So, you don't want to be eating pizza and worrying about the lead here and stuff like that. And there's another important thing, too, to consider is that, the whole idea of acid drainage is, I don't know, everybody has kind of a feeling of what acid is. Everybody has kind of a feeling of, stuff coming out of the mountains and coming from different places. What happens when you start combining them? Well, you guys like coffee or tea?
Yes. Yeah.
Well, this is what some acid mine drainage actually looks like. All right? And this is perfectly good. Now, some of you may have remembered earlier this last year with the governor making a political statement. You remember what he did? Oh, the Animas River. Took a glass full.
The Animas.
Isn't this great? That was after something that we're going to talk about here in a couple of minutes. Now, what's the pH of this, do you think? All you chemists?
5.
Yeah, it's about 5. I used to measure coffee at a place I used to work at routinely because we were doing water quality work. And the total dissolved solids were really high. Okay, duh, it's coffee. But the pH was often about 4.5. So just keep that in mind as we go through the rest of today, because I'll be commenting on a few of those things. So my motivation for this presentation is really not so much about chemistry. I'm not going to throw a single chemical equation at you today. Anybody disappointed? Which means you can enjoy your pizza. You won't have to worry about taking down any copious notes, trying to figure out what I was telling you. So you're not going to see any of that stuff today. We're going to talk more about concepts and empower you a little bit with thinking about what the different aspects of acid mine drainage are. Now, there has been a heck of a lot of press lately. And we'll look at one of those more notable ones in a little while. But it's been around a long time. This has not happened like just this decade or the last decade or the decade before. I mean, at a minimum, it's probably been known as an environmental concern for probably close to 80 years. So we'll talk a little bit about that as well. And so I hope that today you'll come away understanding what the problem is in a very general sense. You're not going to understand the chemistry behind it. You're not going to understand oxidation and acid generating potential and all that necessarily, but you'll be able to recognize the problem. And then on a positive note, I'll talk about some successes. And you'll talk about some successes and some things that have actually worked. Because I don't know about you, but when I see a problem, I mean, what's the reaction? There's a problem here. Let's fix it. Anybody have that reaction? Yeah. Let's deal with this thing. Now, I don't know about you guys. Sometimes it's wasted energy to point at who caused the problem, right? Sometimes it's more important to fix the problem. So we're going to focus a little bit on some of the things that have worked. So in order to do all this, I'm going to take a classic approach. You guys are all getting nervous. All right? So what I'm going to do is, in a moment, you guys can start looking around furtively at each other about who you want to sit with and talk about things with. All right? You guys have already self-selected a little bit. I watched that as you guys were coming in. You're sitting with all your friends. So that means you can talk to your friends, right? This is great. Everybody's looking around. So what are brainstorming rules? It's kind of like there are no rules. Everybody has a good idea. Just don't dismiss somebody else's idea out of context.
No critique.
Exactly. So respect different ideas. And I want you to get into groups right now. I don't care how many groups there are. A group of one is, probably not that cool, but that's okay. I want you to talk about what you think acid mine drainage is, just based on your experience. Okay? Go! Go for it. I want to see you guys talk to each other. Come on, can you do that?
Yeah, here. I think it's
When they mine, they have that leftovers
You're eavesdropping.
yeah. So these things are acidic materials. I think it's more leaching from the yeah, that makes sense. So, but I don't.
Some of them like that.
I thought that's where they watered it. They left. So, and something broke it.
What's coming out of the ground?
Right. See, I thought that was so this could be naturally acidic water. Yes, a lot. Well, what happened with the yeah, and then it came down because that included all the So is that acid?
Where's Marty?
Where's our, where is our Geochemical science yeah, and I guess right, might it does. What's the scale? Do you know whatever that stuff is? Oh, so the lower you get, the more acidic. Oh, okay. You really want to have a pretty control of the body. Right. That's why
Now this is, if you want more pizza, this is a good chance. You leaders.
I wondered if you'd be here. So do you know the answer to
Okay, how many minutes did I give you? 15? 15? Did about 3. Okay, now, how are we doing? Even though I said 10, have you made progress?
Yeah.
Sure. Good. Now, I usually say things like 10 in case I have a whole bunch of really serious introverts. And it's very clear to me that no one in here falls into that category. So can we go ahead?
Yes.
Okay, now I'm going to turn you back into introverts. What's your idea of acid mine drainage in 3 or 4 words or less.
And 3 or 4 words.
It either comes from what you dug up or how you dug it.
Okay, so there's some process involved.
Yes.
What about you guys over here?
Us?
Yes, see, I'm trying to get the attention of.
The Earth's very porous and water gets in and water gets out.
Okay, so we have some sort of circulation going on. Okay, how about you guys over here? Who wants to volunteer? Of all these groups. Who wants to volunteer? Who wants to be voluntold? Go ahead, Lisa.
Summitville.
What now?
Summitville.
Summitville. You went for the one-word synopsis.
I did.
Okay, what does Summitville mean to everybody in here?
Poison water.
Poison water,
Super fun site ever.
super fun site, all sorts of exciting things.
Gold mine, cyanide.
Gold mines, cyanide, all that sort of fun stuff. Okay, that could be another topic entirely. Okay, is there anything we haven't touched on? We touched on, stuff going in and out of the earth. We talked about circulation. We talked about this place called Summitville, a big mining disaster. What else can we add to this?
Acid, that it's below pH of 7.
Below pH of 7. What's pH? Everybody know? In general, without getting too involved in
Isn't it
H's and
something you go to
OH's and stuff
school
like
for?
that?
No, that's that would be the FUD.
Yeah.
Using shampoo advertising, right?
Yeah, something like that. But anyway, it's just a measure of acidity. And if it's less than 7, it's acidic. All right. So, how does this look? What's your reaction to this one, everybody? Ugh. That was pretty nasty, doesn't it?
Is this the Animus one?
This is the Gold King mine, the one that turned the Animus orange. So, where did all the water come from? That's sort of like, where did the forest fire start, right? You follow the black back to the point where the ignition point was, something like that. Well, it's important to point out some of the mechanics of the things that go on with mining here, just so you have a little bit of background. This is not all natural topography here. Pretty much everything that's stacked out here came from inside there. All right, everybody cool with that? This is an important thing to consider later in the talk. And very often, all the material that's out here is waste rock. It's stuff that they did not haul off to the mill. It didn't have anything of value in it. So really, once you get it out of the hole in the ground, you leave it right there, and then the good stuff gets taken somewhere else to get processed more. So this is a pretty significant pile. The location of this, and this is north of Silverton a little ways, and we'll see a better location here coming up in a minute. But this is my favorite visualization toy, Google Earth. And this is where that previous picture was taken, right there. Okay, if I jump back, you can sort of see the shape of this whole area, and then you can see it replicated down in here, except what's the difference? The color, right? Taking a different view on it, here's that same feature down there. And why do you think I set this thing up so that the feature of interest is way down low? Okay, if I'm trying to illustrate something here,
Looks like
am I going to put the feature of interest down at the bottom?
On top.
I'm sorry, Lisa, go ahead.
Are those closed up vines on the top?
Well, they're not necessarily closed up mines. It's all related to the big underground structure that's through here.
So adits and
Yeah, there could be little adits going in, there could be air shafts, all kinds of different things related to the extraction of ore from underneath. Now, by the way, what is the definition of ore? Anybody know?
With stuff in it.
It's got good stuff in it. Right. Really, definition of an ore is anything you can take out of the ground and make money on. That's pretty basic, isn't it? So, I mean, it's not restricted to any particular commodity. Here's another view of that same place. Is there anything really disturbing here? Here's the future iron-stained dump area. Do you see anything else odd in this picture that might concern you?
Well, the slopes are all bare, and there's no cover, no vegetation to slow any any
Right, okay, so I
runoff.
mean, we're right at tree line here. Okay, what does that imply about snow? Might get a lot of snow, right? So there could be a lot of runoff. This gets back to some issues that happened with Summitville a number of years ago with excessive snowfall, but we won't talk about that too much. But what I'm really curious about is this little thing right here. See that? That's somebody's vacation home. Okay, now, so what are you all thinking right now? Oh, beautiful vacation home with a great view. But actually, there's something even more serious than that. And this is a caution that's kind of tangential to my talk today. And it also has to do with cleanup and understanding the problem. Would you like to have a cabin in the mountains with a beautiful view like that? It'd be pretty nice, right? Is this a big mining district?
Yeah.
You betcha it is. In fact, later on when I talk about an abandoned mineland program, I don't have much information on this area because a lot of it's private or patented land. So if this guy thought, whoo, there's my vacation home, I'm going to retire here, about a tree line and lots of snow. If this just happens to be an old mine right here, he thinks, oh, that's cute, I like an old mine, maybe I'll be rich someday. If it has an environmental problem, guess who owns the environmental problem now? That guy. Doesn't matter if the biggest mining company in the world caused a problem. You buy the land, you get the problem. Now, what does that do for Good Samaritan cleanup? Like if you buy a piece of property to clean it up, fix the problem, yeah, you're taking a risk, aren't you? So if you ever buy property in the mountains, have an environmental assessment done on it first, just like an appraisal, to make sure there aren't environmental problems. Okay, enough of that scary stuff. This is what the Gold King area looked like when people still saw things in nice black and white perspectives. Things are considerably more developed. So, I mean, there's a lot of material that came out of this area. This gives you another perspective for where we are relative to treeline Venice. I mean, it's up there. And this is what the big spill produced. This is just a couple of days later. And I did see a very kind of funny in a perverse way of what the river looked like, and all kinds of signs saying, stay out of the river, and a bunch of people kayaking in it. You want to do an Eskimo roll in that river in a kayak? I don't think so. But very, very nasty problem. Now, not to do the lemons and lemonade thing too much, but this is what it looked like a couple of weeks later. Okay, now, this is up and above, looking down a little bit. But, do you think there's any damage through here though still? Okay, I'm gonna jump back. See this little island right through here? Look at the shore of that island in the next picture.
So long.
You have a little bit of staining around it. Okay, so does that mean that the whole river lost a lot of pH? That the whole river got very acidic? Or is there something else going on here that we should pay attention to?
Sediment?
It's the sediment. Because we'll talk about this more in looking at some of the other problem areas and how they've been fixed. But the problem is that acid produces dissolving, okay? So I could make geologic time run in this lecture, although some students in my lectures probably do think the lecture goes at geologic time. Okay, if this is relatively acidic, and I pour it on all this stuff, what's going to happen? Theoretically, I could dissolve metals out of this, right? Because I'm adding oxygen to a sulfur system and so forth. And what often happens is that there's a lot of geologically occurring alka-cells are out there called carbonate. And so even though a lot of acid-generating material might accumulate underground where there's been natural oxygenated water circulating with all these nasty ores, a lot of times as the material goes out, it does tend to come back to a relatively neutral pH by reacting with natural carbonates in the rock. Not always, but sometimes. But the big problem is that even though the pH might not have been too bad, the metals stay in solution. So you're not going to burn yourself in that water. But is the metal content bad? That's the big deal. That's the big deal. So how did this thing happen? Well, this is kind of a nice generalized interpretation of what happened just before the blowout. Well, this is not a particularly good cartoon. It's somewhat idealized. Okay, this is the big nasty area with all the pickup trucks that you saw earlier. Here's the portal going into the underground workings, and all this blue stuff indicates that it's full of water. All right, and this is part of a backhoe. Isn't that clever? It's very clear, isn't it? That's like a backhoe without most of the backhoe shown. And this backhoe is happily scooping things out. And here's a little bit of a water spurt. All right, now, have you got the visual there? You got kind of an idea what's going on? Okay, so here's the whole scenario, all right? With things, you know, this is where everything came out from underground, and here's the bigger system and stuff. I want 2 voluntoles. Don't all talk at once. Oops. Oh, you tech guys saw that picture was going away, didn't you? All right, so who are my volunteers? Okay, I'm going to shed some light on the situation. Wake you up. Okay, Alex. Now, Alex, because I'm a fair kind of a person, I want you to pick the next volunteer over here. You're gonna grab Adam? I planted these guys, really. Come on up, guys. Now, you've already seen some stuff about where all this stuff might have been coming from. Can you draw kind of a picture up here for us of what you think is going on in terms of all the water pressure and everything else? You get to use the whole board, both of you. And you can use any color you wish. And how much time do you want? Or do you want to work together, or do you want to work apart?
My picture's gonna be really rudimentary, so would you want to work together? Yeah. Okay.
Okay, which side do you want to be on? Okay, go for it. See, like all these decisions going on here? Now, here's the other part. It's kind of cool. Get to work, guys.
Okay, so we're drawing the macro and...
Whatever you want. Whatever you want. Whatever you want. What's this scenario look like? How did all this water get in there? How did things build up? Okay, now, we can make this sort of like ESPN, you know? We can have, should we cheer for them? Or should we say things like, oh, you're getting warm, you're getting cold? What should we do? How about you guys? I tend to really believe in positive reinforcement. So if you see something that looks not so cool, don't say anything. But if you see something that looks really cool, go, yes! All right? How are they doing?
Trying to get it right.
They're trying to get it right.
Yeah, they're being scientists.
Isn't that awful? People being scientists? What a concept. Now, see, they're also being very clever, because you notice how they're obscuring their drawing? Now, I've seen these guys lecture before. Usually they're wide open. You know, here's what I'm doing. These guys hit a challenge, okay? Notice the arm motions. Is this good stuff? Yeah, you're darn right it is. Hey, Brian, there's still pizza. It's power food. Have some. Okay, while we're watching this stuff, you guys think about what's up here. You see any connections between this thing and this whole, you get to work. You see any connections here between these things scale-wise?
It's different. Not big a hole.
Okay, I want you guys to step back as soon as you're done, Adam.
Okay.
Okay, and I want you to describe to us what your drawing is indicating. What do you think the problem is? Not with your drawing, but with this.
So void spaces and
Okay, void spaces, write that down. Okay, Alex, your turn.
Water pressure is increasing.
Okay, water pressure is increasing. You put that up there. Okay, now, because you guys have really suffered being up here, and you haven't even broken a sweat either. Ask these guys if they can add to this.
Well, I think they want to add more research.
There's more to this picture. Okay, what else should we add in here? Tell them what's going on. What else do you have on here?
so we have water source, where the water's coming from.
Okay,
So snowpack melting and percolating through rock.
okay, cool. Want to put that up there too? What else? What else do you think could go into this whole thing?
Uncontrolled drainage.
Uncontrolled drainage. Go ahead, Cassie.
The interior erosion, as people were going through and mining it out, they're stirring dust up and moving everything around so it dissolves in the water faster. So I
Oh.
can open up.
Okay, I'm going to point out something when we get to another slide here in a minute, which has exactly to do with what you're talking about. But yes, all that movement, removing a material, destabilizes stuff, and groundwater gets in. Go ahead, guys, what else? I don't know. What do you think?
Dissolving metals being dissolved.
Yeah. So if all this is underground, and we start running water through it, and we have all kinds of void spaces and stuff, we have a lot of water coming in.
Dissolves limestone and the solution gets more.
Okay. Rocks getting moved around and stuff. Cool. Go ahead and write that down. Okay, so at this point, everybody should have some kind of an idea of what the processes are and all the different complexities of the whole scenario. How have these guys done? Have they done well?
Yeah.
Yes. Good job, gentlemen.
Am I done?
You were good. Thank you for doing that. Now, is there anybody in here who is thinking, gosh, I'm glad I didn't go up there? Like all the rest of you? Well, one of the things that's really difficult sometimes is that in this day and age of sound bites and everything else, sometimes it's really hard to be analytical about what's going on in a particular scenario. People hit you with things like acid mine drainage. You look at that river when it was yellowy orange color, what did you think? Like, ugh, bad, ruined it. Okay, I'm not making excuses for anybody, but was there a tendency to think, why did it get that way? How can we fix it? Can we fix it? You know, what are all the issues? So it's important to be able to do like what these guys did to understand what's going on. So we're going to work in our same groups here again. If I can get my mouse back here. And I'm going to put up a video here. Now, this video was done by some folks up in Denver, and I don't know, you think I can trust this thing?
Sure.
This is done by some folks up north. They did a really good visualization of the whole area. And in your groups, you can talk about what's going on here. So start talking about what you're seeing. This is going to go for a little bit here. These are outlines of different workings. Here's the Gold King. So keep talking, it's okay. Don't be shy. Should my glasses. Now, sample hand moving around there. That hand is not me.
And it looks like it's moving down a
Okay, I'm going to pause this for a second to answer Cassie's question in a little more detail. Now, the question that Cassie had a minute ago, or comment, was about water getting into things and stuff. In about I think it was 1986 or so, there was a big mine up and through here. You may have seen the outline of the workings. You'll see them again here in a little bit. But see that little lake right there? That's called Lake Emma. It's now former Lake Emma. Because one Sunday, fortunately, some guys were mining upwards in an active mine. And they punched into the bottom of the lake. So that's sort of like drilling into the bottom of a bathtub when you're in the basement. That wasn't very smart, was it? Okay, but we'll continue. That's the discussion for another time. So keep talking, keep looking at this. This is good stuff. Keep track of where the Gold King mine is. It's down in the lower left. Those are all the underground workings.
Oh, that's all the stuff. Oh, so stuff from other mines. What?
Gravity.
Yeah.
From many sites are in So this all
You'll see something else up here in a little bit too, and that is the word bulkhead. Bulkhead is a fancy word for cork in the mine opening. And that's what you saw that faux excavator tearing out. Okay, so here's the Gold King again.
What's the difference in colors?
Different levels, elevations.
All right.
So are these like the tunnels or things?
Okay, now keep looking. I mean, these mines, this is an actual spatial relationship between all these mines. And not all the geological connections are made between them, like faults and so forth and other mine workings.
Rob, where's the water table?
You'll see. Good question. It's right there.
Good timing, Rob. How'd you do that?
Well, we worked together on that. Remember we rehearsed it? Now this is hypothetical groundwater table. This is the water pressure table. That doesn't mean there's water evenly distributed throughout the whole mountain. A lot of this is solid rock. But that's the level that you would expect to intercept the water at. You're going to see another one in a second, which is slightly more disturbing too. See, 12 bulkheads. Okay, so corks got put in all these adits, all these underground tunnels, entrances.
Is this all gold now? You can't put gold.
Yes, base metals and precious metals both. There's some copper, lead, and zinc, but mostly gold and silver.
Those are the bulkheads?
Those are the bulkheads, those little red things. They're being circled by somebody many months ago. By the way, the person who did this may very well be down here to give a talk on geochemical modeling at some point. Stay tuned. Now, what's this red thing, or the brightly colored thing? You might think of that as post-cork. Is that exciting or what? In kind of an unnerving way.
Is water table higher because of the bulkhead?
Exactly, Ms. Clements, exactly. The question was, is the water table higher because of the plugging? The answer is indeed yes. This is all up just north of Silverton. Okay, so did that give you a sense for how complex this whole scenario is, it's not just as simple as saying, ooh, bad stuff's coming out, we'll just plug it up. Because what happened was that that low mine, the Gold King, got plugged up and it filled up. Now, just like that T over there, if I wanted that T to stop getting so dark, what do I do to the tea bag? You take it out. Okay, that's pretty brainless, right? You all know that. But if you imagine all that water stacked up in there, reacting with the surrounding sulfides, is it going to get nastier and nastier and nastier over time? Yeah, there's a good chance that it will. So, do you understand the problem? A little bit? Okay. It's not confined to just Colorado. This is leakage coming from behind a reclaimed coal spoil, a pile of coal waste in Ohio. This looks pretty, doesn't it? This has a pH of about 2 compared to 7. And that's just coming from natural sulfides within the coal itself. This is the human-made channel that is catching all this nasty water. And this is the pond that they're treating it in. That looks pretty cool, doesn't it? Now, the scary part is, this pond is almost full of sediment. I chucked a rock out there, and it landed in the middle, and the rock didn't sink more than about halfway. Because there's that much sediment in it. The rock just hit the top. And they add caustic up here, a very, very basic high alkalinity solution up here to kind of offset the pH. This water, as nasty as it is still full of a lot of iron and stuff. You can kind of tell from the rusty material. But at least it's not super, super acidic. But it's still a disposal problem. What are you going to do with it? Build another pond, let it dry out, cover it with clay so rain doesn't get in on it. I mean, those are some of the things that have to be done. So let's move on to something more positive. This is up in Bonanza area. And this is near the Raleigh 12 mine, some you may know of. If you go up past the town of Bonanza a little bit, you come to a fork in the road, fork in the creeks. And this is the one that goes up to the right to a place called the Superior Mill. This is what it looked like back in turn of the century and up into about the 30s. Lots of activity, lots of water. See all that? What does this look like? You think that's all the junk that came out from underground that they built facilities on? Yeah, you bet. Here is that same spot, just to jump up. This same mill up here, this very large building that you can see, is right up in this area. This has been somewhat abandoned. But notice this dam down here. And a whole bunch of that goo piled up behind it. And there were actually several dams later on, because mining did restart and continue up there. However, as nasty as it looked, as recently as 1994, there have been some positive things done. Now, this of course is not an actual image of the area. This again is Google Earth, but this is a recent bit of satellite imagery. Notice that those dams are gone. Asarco, a mining company that inherited this place through a purchase, worked very closely with the BLM and particularly the EPA to avoid Superfund status. The reason they want to do that is so they have more flexibility over remediating. But what ended up happening is they took a lot of this material out and a lot of other bad bits of mine waste and moved them into a place where they're out of water circulation. They capped them and covered them, and I won't say there's no environmental problem, but I will say that there is much less of one. This particular adit, this is what it looks like now. Now it's been corked off, and it's not like totally plugged. They're allowing water to come out. It has a fairly high pH compared to what it used to be. I personally measured this stuff, and it's about a 6.7 compared to rainwater of about 5.99. That's not too bad. And if you want to read more about this whole thing, there's a nice description of it. This is on the CDE website, website. But you can go read there, read all about this thing and what they did in a positive way. And there's some other things that have happened too. For those of you who know the Crete area fairly well, you know there's been a lot of mining done up there. And there's a big citizens group going who's got all kinds of good work going on. You can look at their website if you want to get involved with dealing with a lot of these issues. They have an annual water sampling rodeo, which is really kind of cool. Because one of the things that is very important in understanding natural systems is that we have spring runoff, right? And then theoretically, right before the start of the winter season, water is going to be at its lowest. So if you get sampling periods there done, and if there are a lot of samples, you get a lot of people to take the samples, you get them done relatively instantaneously at the same time. And this is the kind of stuff that really is, you know, if you're worried about dealing with this sort of stuff, you can make a big difference and be invested in fixing, or at least reducing some of these things. Another group that's really involved with stuff you may know about already, and this is good old, I'll just go right to Facebook. No, I'll go to this one. It's Trout Unlimited. Trout Unlimited does all kinds of stuff. Maybe not directly with mine drainage per se, but certainly in terms of help keeping water out of bad places and helping to restore things. And the person to contact is this guy right here, Dr. Marty Jones. A lot of you guys know him, don't you? He'll be more than happy to give you more information. Everybody staying awake post-pizza? Now, I'm going to show you some Google Earth things here in a minute, but if you want to find this particular report, just do a search for Colorado Geological Survey and then use abandoned mine lands in your search. And you can get a whole report on things. They did a huge project on stuff on Forest Service lands, and they have all kinds of cool pictures and stuff. And there are a whole lot of people involved in this whole thing. And it was quite the show. And you can download all kinds of cool files and stuff. You can get down KML files, KMZ files. For you guys who are familiar with Google Earth, you can put them into Google Earth and look at them. You can get geodatabases for GIS work as well, if you want to do things. And again, this is the kind of stuff that you can start taking action, thinking about things. And this may turn out to be kind of a frightening thing at first, but we'll zoom in on the world of Colorado in just a moment here. And you'll see an awful lot of material on there. Not everything. See, I love choking computers with data. Isn't that great? Isn't it cool when you can get Google Earth to kind of slow down? Once we get a little closer, though, it won't be so bad. These are all mine sites or things that have been assessed on Forest Service lands or publicly administered lands in Colorado. That in itself looks kind of nasty, doesn't it? It's like, geez, there's a lot of stuff there. We'll wait for it to kind of settle down and catch up here in a minute. But the things that are available, and I only downloaded a couple of the KMZs, but we can look at mine openings here with environmental concerns. All right, what are our options here? Unknown, none, all the way up to extreme. All right, because I know you're all into extreme stuff. I'll start taking off some of these guys. I'll take off these waste rock piles entirely. And the mine openings. And the temporary ones. sightseeing tour. And then we'll zoom in. See that little red thing in the middle? See the colors in the background? And you can start looking at all these things if you so wish. That's the information on that particular area. Now, that makes a lot of sense, doesn't it? When was the last time you walked around in the woods and ran across an object ID? Well, the key thing here is you can kind of go down through these things and you can look at, there's information there about what the area is like and what has happened there. But if you look at the comments section, that's even more important. Okay, well that site is where it is in the real world sense. And large dump with two-tone gray. Okay, isn't that cool? There's all kinds of information sometimes about, you can find actual assay information about the water drainage, what the pHs were, the field stuff, on and on. And this is all done with a standard field form by a lot of different people. So there's a lot of good information in this thing if you want to find out more about what's going on public lands. And the good news is, I'm done. Thank you very much for listening today. Thank you, and I engineered some time for a little bit of questions here.